Hello students, welcome back. So today in this video we are going to start our next chapter of class 10, that is acids, bases and salt. You might have heard about these terms acids, bases and salts. Okay, you know, basically all the elements which are present in nature, they are being classified into acids, bases and salts on the basis of their chemical properties. Fine. Now when we are saying that all the elements, so you know, means around there are more than 115 elements now. 119 elements are there, but the discovery about them is going on. So more than 115 elements are present on this earth, and on the basis of the chemical properties they are being classified into acids, bases and salts. Okay, now see, by looking to a particular substance, if I give you any solution, by looking to on it, you cannot say that whether that particular substance is an acid, a base or a salt, isn't it? So how will we come to know that the substance which is provided to you is an acid, base or a salt? So for that we need indicators. Okay, now indicators are what? Indicators are substances, or you can say they are dyes, D-Y-E-S. Okay, indicators are dyes which changes color when put into an acid or a base. Fine. So indicators are dyes. When I'm saying dyes, you might have heard this, dyes, isn't it? The dyes are some colored substances. Okay, so indicators are also some colored substances, dyes, which when you put into an acid or a base, whatever their original color is, they will show a change in color, by which we can recognize that whether the given substance is an acid, base or a salt. Okay, so indicators are dyes, D-Y-E-S. Fine, not D-I-E-S. Fine. So now see, indicators, when we are talking about indicators, so indicators can be of different type depending upon their origin. Okay, so depending upon their origin, indicators can be natural indicators, or they can be artificial, or I can say synthetic indicators. Fine. So indicators are of two types. On the basis of what? On the basis of origin, that is from where they are taken. On the basis of origin, indicators are classified into two types on the basis of origin. Okay, in natural and synthetic indicators. Now, as the name suggests, natural indicator means they are obtained from nature. Okay, and artificial or synthetic indicators means they are man-made indicators. Okay, let us see few examples for them. For natural indicators, the examples can be litmus, then turmeric. Litmus, I will explain what it is. First you see turmeric. Turmeric means haldi, ठीक है, जो हम घर पे यूज करते हैं. Then red cabbage extract. This is also a natural indicator. So we have seen three examples for natural indicators. One is litmus, turmeric, red cabbage extract. Litmus is the most common indicator which is used in our laboratories as well. Okay, we'll see a little bit in detail about it. Then let us see a few examples of artificial or synthetic indicators. So artificial or synthetic indicators, the examples are methyl orange and phenolphthalein. Okay, methyl orange and phenolphthalein. These are the two synthetic or artificial indicators. So let's see the different indicators and their color in presence of acid and base. Fine. As I told you, the most common indicator which is used in our laboratories is what? It is litmus. Fine. You know, litmus, it comes in form of papers also and in form of solutions as well. Okay. So this litmus, it is coming in form of what I said, papers, as well we get litmus papers in our laboratories, strips. Okay, fine strips are there and litmus solution is also present. Now actually, you know, this litmus, as I told you, it is a natural indicator. This litmus is extracted from a plant called lichen. You might have heard about it, lichen. Okay, I'm writing here, just see, lichen, isn't it? You might have heard about these plants, symbiotic association of algae and fungi. Okay, so litmus is extracted from these plants called lichens, and this litmus is basically a purple dye. Okay, that means its neutral color is what? Purple. But for the sake of convenience, this litmus is taken as blue litmus or prepared as blue litmus or red litmus. Okay, so that it is easier to find out the color in acid base and to find out, to indicate the given, whether the given substance is an acid or a base. Okay, so let us see their colors. This table is very, very important. See, the first indicator is blue litmus. As I told you, litmus occurs in form of what? Blue and red litmus. Both blue litmus and red litmus, what is their neutral color? Purple, because litmus is a purple dye. Okay, now blue litmus in acid will change into red. Okay, when this blue litmus solution comes in contact with an acid, okay, then it will change its color to red, but in presence of base it will remain blue only. Okay, so base and blue litmus, BB, blue base, BB, blue base. Okay, then red litmus, again the neutral color is what? Purple. Okay, in acid it remains red. Always remember, litmus solution in presence of acid, it will be red. Okay, whether it is blue litmus or it is red litmus, but in case of base it will turn to blue color. Fine. Then turmeric. Turmeric is a very common indicator which we have seen in our homes as well. So turmeric, its neutral color is yellow. All of you might have seen at your homes. Then acid also, it remains yellow. This you can test at your homes only. Okay, you take some lemon juice and turmeric powder, add lemon juice and turmeric powder, the color will remain yellow, but in base it will turn to red. Okay, this also you can test. Take turmeric solution, you can prepare at your home. Okay, add some water in turmeric. Okay, and you add some soap solution, okay, in that turmeric solution. So the color will change into what? It will change to red in color. Okay, the yellow color changes to red in presence of the base. Fine. Then methyl orange. As I told you, methyl orange is a synthetic indicator, artificial. So methyl orange, its neutral color is orange, but in acid it turns red and in base it turns yellow. You need to remember these colors. Then phenolphthalein, its neutral color is colorless. Okay, no color, like water it is. And in acid also it remains colorless, but in case of base it becomes pink. Okay, it changes its color to pink. Then another natural indicator we are seeing, red cabbage extract. Its neutral color is red. In acid also its color is red only, but in base the color changes to green. Okay, so these are the different indicators and what is their neutral color and their color in acid and base. Okay, you can take a screenshot of this. It is very important table. On the basis of this the questions come in your board exams. Now there is one more type of indicator which is known as universal indicator. Actually this universal indicator also changes its color in acid and base to help us to find that whether the given substance is acid or a base. Okay, but the difference is universal indicator, it helps us to find out that how much acidic, okay, how much acidic or basic a substance is. Fine. Whereas these other indicators which we have discussed now, those were only helping us to find out that whether the given substance is an acid or a base. Fine. They were not telling how much acidic or basic it is. Okay. Even we can find out that whether the substance is neutral in nature by using universal indicator. Okay. Universal indicator also strips are coming as well as solution is there. We will see this universal indicator further in detail, but just now you remember that there is one universal indicator also which helps us to find out that how much acidic or basic a particular given substance is. Okay. Then the next type of indicators are called as olfactory indicators. Fine. Now olfactory indicators are those indicators which are related to the sense of smell. Okay, this word olfactory means related to sense of smell. Fine. So over here, as I told you, they are related to sense of smell. So that means that these indicators change their smell, okay, their characteristic smell when coming in contact with acid or a base, okay, suitably. Fine. So the two common examples for olfactory indicators are onion extract and vanilla extract. Onion extract, actually onion is a thing which we all use at our homes, and you know there is a characteristic smell of onion. So when a basic solution is put in onion extract or onion extract is put in basic solution, then the characteristic smell of onion cannot be detected. Okay. Whereas in acidic solution, the smell will remain intact. The characteristic smell of onion will remain intact. Okay. Same way in case of vanilla extract in base, that's why I'm writing like this, in base. When you put vanilla extract in base, the characteristic smell of vanilla will not be detected. Okay, we cannot detect that. But in case of acid solution, the characteristic smell of vanilla will remain as it is. Fine. So these are the examples of olfactory indicators. Okay, so we have seen the different types of indicators. Okay. Some were helping the previously in those table which we have seen, the indicators there, those were helping us to find out whether the given substance is an acid or a base. Universal indicator, it helps to find out how much acidic or basic it is, and both the normal indicators as well as this universal indicators changes color to detect that, whereas olfactory indicator is related to the sense of smell. Stay tuned for our next video, okay, and go through this thoroughly.